The figure above shows a cross-section of a drinking glass. As light goes from the air to the glass, and then it's going to be hitting the liquid interface. Okay. Now, when theta is equal to theta 1, two bright spots will appear on the bottom surface of the glass. Okay. The spot that's closer to point P is called X. The spot that's farther from point P is called Y. Okay. So let's just say something here, right? In my opinion, X will be here, and Y is going to be somewhere here. Let me show you why. So the light is going to hit the liquid interface. It's going to reflect back here. So X is the result of the light reflecting at the glass liquid interface. So X is the result of the light reflecting at the glass liquid interface. But then some other light will keep going. It's going to travel through the liquid. It's going to hit this interface between the liquid and the air. It's going to reflect back, and it's going to then refract, and it's going to form Y. So Y is the result of multiple things, reflections and also refractions, but X is much simpler. That's why X is going to form closer only to a simple reflection, while Y is going to form farther due to reflection and also refraction. Okay? Now, in a coherent paragraph length answer, describe the processes involved in the formation of spots X and Y. When theta is equal theta 1, include an explanation of why spot Y is located farther from point P than spot X, and what factors affect the brightness of the spots. So basically, spot X is the result of reflection at the liquid glass interface. Okay, the liquid glass interface. Okay, while spot Y is due to a number of things, right? It's going to be the reflection. It's going to be the result of the refraction of light at the glass liquid interface. Let me show you how. So refraction, that's the first thing. As you can see, the light bent away from the normal. Number 2, reflection at the liquid air interface. Reflection at liquid air interface. And finally, refraction at the liquid glass interface. And that's where spot Y forms. And so multiple paths will be taken, multiple things will be taken. Why is spot Y less bright? Because when light will hit the liquid, right, glass liquid interface, some of it reflects to form spot X, so some light intensity is going to be lost there. And also when the light hits the liquid air interface, some of it's going to be actually going in the air, transmitted in the air, basically. So you're going to be also losing some light intensity there. Okay, so now we covered what's the result, what's the cause for spot X and what's the cause for spot Y. Now, we also covered why is spot Y going to be less bright, right? So spot Y is less bright for two reasons. Some light is lost due to reflection at the glass liquid interface to form spot X, and some light is lost by being transmitted from liquid to the air. And why is spot Y further? Well, because of the multiple things that have to happen for it to form, which is the refraction, reflection, and then one more refraction. All of that will result in it forming a further spot. Now back at the question. When theta is increased to theta 2, one of the spots becomes brighter than was before, but both spots remain. We're going to be having TIR, which results in one of the spots becoming brighter than it was before. Okay, so what's happening is that the theta 2 is now bigger than theta 1. And so this will result in a higher angle of refraction, which will result at TIR at the liquid air interface, meaning that no light will be transmitted into the air, no light brightness will be lost into the air, and so Y will be brighter than before. X, same brightness, but Y will be brighter. Okay? So now let's draw the arrows. So this arrow is going to reflect back, and it's going to be forming spot X, but it's going to also refract here at the glass liquid interface, refract away from the normal. Then it's going to reflect back, and then it's going to then refract toward the normal. It's going to be forming spot Y, with Y now being brighter than before because no light will be going into the air. Okay. So which spot becomes brighter? It's going to be spot Y. Why? Because basically TIR at the liquid air interface, so no light is transmitted to the air. Okay. When theta is further increased to theta 3, one of the spots disappears entirely. We draw a ray diagram to represent the spot that forms. So now we're going to be still having spot X forming. That would not be affected. But now spot Y is gone. Why? Because we're going to be having TIR at the glass liquid interface. We're going to have TIR there, and so no light will exit into the liquid, and so spot Y is going to disappear. So spot Y will disappear because all the light will be reflected at the liquid interface. So all the light is reflected at the liquid / glass interface. No light is able to travel to the liquid. Okay. And so now, so theta 3 is more than the critical angle for glass to liquid, which is how TIR was able to happen. So spot Y disappears, but spot X remains.